Hello, and welcome to Astronomy Daily, your essential guide to the latest news from across the cosmos. I'm your host, Anna.
And I'm Avery. It's fantastic to have you with us for another episode. We have a very diverse lineup of stories for you today, spanning from low Earth orbit to the depths of the asteroid belt.
That's right, Avery. We'll be starting with a brilliant display of international partnership as a Chinese rocket successfully launches a payload, including some very special satellites designed and built in Mexico.
Then we'll delve into a bit of mystery. The U.S. Space Force's secretive X37B spaceplane is about to embark on its 7th mission. We'll talk about what we know and what we don't, including a groundbreaking NASA experiment it's carrying that could change the future of deep space navigation.
From there, we'll turn our eyes to a celestial object you may have heard about online recently. Chiron is in retrograde. We're going to break down what Chiron actually is, it's a fascinatingly weird little world, and explain the astronomical reality behind retrograde motion.
And for our final story, we're visiting an old friend, the dwarf planet Ceres. Exciting new research suggests that it may have once possessed all the necessary ingredients to fuel life, offering a tantalizing glimpse into its ancient past. It's a packed show, so let's get right to it.
Let's kick things off with that story of international collaboration. On Tuesday afternoon, Chinese commercial launch provider CAS Space successfully conducted the 8th flight of its Kinetica 1 rocket, lifting off from the Jiuquan Satellite Launch Center in the Gobi Desert.
It was a full ride, carrying 7 different satellites into orbit. The payload included things like a synthetic aperture radar satellite and an Earth observation satellite. But the real headline grabbers were 2 tiny spacecraft designed and built in Mexico by the private firm Thumbsat.
And when we say tiny, we mean it. These are Pico satellites, each weighing about 100 grams. It really goes to show how miniaturization is democratizing access to space. But Avery, these Thumbsats have some pretty unconventional missions, don't they?
They really do. According to the company, Thumbsat 1 is carrying what they call a selfie payload. Its goal is to capture a mirror selfie of itself in orbit, which is just fantastic. Meanwhile, Thumbsat 2 features an artistic payload, aiming to blend science with creativity. I just love this approach. It's a powerful statement that space exploration is a human endeavor, about expression as much as it is about data collection.
It's a beautiful sentiment. The collaboration extended to the hardware as well. CAS Space reported that they used a custom-built satellite deployer designed through close cooperation between their engineers and the team from Thumbsat. This wasn't just a taxi service, it was a true partnership.
And the engagement doesn't stop once the satellites are in orbit. Thumbsat is planning to install ground receiving stations across Mexico. This will allow students, hobbyists, and enthusiasts to track the signals from orbit using free antennas and software. It's an incredible STEM outreach initiative baked right into the mission.
CAS Space is rightfully describing this as a landmark in Sino-Mexican space cooperation, and it's a significant milestone for China's commercial space sector, giving them a foothold in the North American market. The Kinetica 1 rocket is proving to be a highly reliable and sought-after vehicle.
No kidding. With this flight, it's now deployed 70 satellites weighing a total of more than 7 metric tons. For the space nerds out there, the rocket is 30 meters long, weighs 135 tons at liftoff, and can carry up to 1.5 tons to a 500-kilometer sun-synchronous orbit. It's a real workhorse. All right, from a very public and collaborative mission to one that is famously secretive. Our next story focuses on the U.S. Space Force's X37B orbital test vehicle. This uncrewed reusable spaceplane is set to launch on its 7th mission, this time aboard a powerful Falcon Heavy rocket from Kennedy Space Center.
The X37B is an enigma. It looks like a miniature, unpiloted version of the space shuttle. And its primary purpose is to test and deploy new space technologies. But the vast majority of its payloads and specific mission objectives are classified. What we do know is that it's capable of staying in orbit for extraordinary lengths of time. Its last mission set a new record, landing after 908 days in space.
That's incredible, nearly 2.5 years. So for this seventh mission, most of the manifest is a secret, as usual. However, NASA has publicly announced one of its experiments that's flying on the X37B's service module, and it's a big one. It's called the Deep Space Atomic Clock 2.
This piece of technology, which is about the size of a toaster, could be a complete game changer for how we navigate in deep space. Currently, navigating a spacecraft far from Earth requires a two-way conversation. We send a signal from Earth, it's received by the spacecraft, sent back, and we measure the round-trip time to determine its position and velocity.
But as you get further out, say to Mars, that round trip time can be 40 minutes or more. It's inefficient and not practical for complex maneuvers or eventually for crewed missions that need more autonomy. This new atomic clock is designed to be far more stable and precise than any clock previously flown in space.
By having such an accurate clock on board, the spacecraft can essentially navigate itself. It would receive a one-way signal from Earth, and by knowing the precise time the signal was sent and the time it was received, it can calculate its position without having to talk back. It's like giving our deep space probes their own version of GPS.
NASA plans to test the clock for a full year, putting it through its paces in the harsh radiation environment of space to ensure it performs as expected. This isn't just an incremental improvement. It's a foundational technology that's crucial for enabling ambitious future missions, especially crewed expeditions to Mars.
Okay, from cutting-edge hardware to a question of celestial mechanics. Avery, if our listeners spend any time on social media, they may have seen a peculiar astronomical phrase making the rounds lately. Chiron is in retrograde. And their first reaction might have been, what even is Chiron?
It's true, it's not exactly a household name. So let's dive in. Chiron is a fascinating and somewhat bizarre object in our solar system. It's what's known as a centaur, a class of small bodies that orbit the sun in the chaotic region between Jupiter and Neptune.
When it was first discovered in 1977, it was classified as an asteroid. But then in 1989, astronomers were surprised to see it develop a coma, a fuzzy cloud of gas and dust, and even a faint tail. This is the hallmark of a comet.
So is it an asteroid or a comet? The answer is yes. It's one of a few objects that hold this dual classification. And the weirdness doesn't stop there. Just last year, astronomers confirmed that Chiron also has its own system of rings.
It really is a special little world. So, what does it mean for it to be in retrograde?
This is the key part. What we're seeing is apparent retrograde motion. The object hasn't actually changed direction at all. It's purely a line of sight illusion from our vantage point on Earth.
Think of it this way. Earth and Chiron are both orbiting the sun in the same direction, but Earth is on the inside lane and moving faster. As we approach Chiron in our orbit and then overtake it, our faster motion makes Chiron appear to slow down, stop, and move backwards against the distant stars for a period of time.
It's just like when you're driving on a highway and pass a slower car. As you go by, that slower car briefly looks like it's moving backwards from your perspective. That's exactly what's happening. And you can't see it for yourself anyway, it's far too faint. Sorry. For our final story, we are heading out to the main asteroid belt to take another look at one of its most fascinating residents, the dwarf planet Ceres.
Ceres is the largest body in the asteroid belt, so large that its own gravity has pulled it into a spherical shape. We got our best ever look at it thanks to NASA's Dawn mission, which orbited it from 2015 until 2018.
Absolutely. Dawn's data confirmed that the famous bright spots on Ceres' surface are made of salts, left behind by liquid that came up from a massive underground reservoir of brine. So check 1, Ceres had liquid water.
Ceres also revealed evidence of organic material, carbon-based molecules on the surface. These are the fundamental building blocks of life. So, check 2, Ceres had the right chemical ingredients. But there was a third crucial question.
For life to exist, it needs a source of energy to power metabolic processes. Essentially, it needs food. And that's where this exciting new NASA research comes in.
Scientists built models to simulate Ceres's interior over billions of years. Their findings suggest that for a long period in its ancient past, Ceres likely had a steady supply of chemical energy.
This energy came from the natural decay of radioactive elements within the dwarf planet's rocky core. This internal heat would have warmed the subsurface ocean, causing hot mineral-rich water to circulate up from the core, creating a chemical fuel source for any potential single-celled organisms.
The models indicate that the peak period for this potential habitability was about 2.5 to 4 billion years ago. It's important to be clear. This does not mean that life definitely existed on Ceres. It means the food was likely available should life have ever gotten started there.
And the implications of this are huge. It suggests that many other water-rich icy worlds of a similar size could also have had their own periods of habitability fueled by this same internal engine early in their history. It expands the search for where life could have once existed. And on that hopeful note, that is all the time we have for today's episode of Astronomy Daily.
We've covered quite the range, from the tangible success of an international rocket launch
To the clandestine operations of the X37B. We untangled the celestial illusion of Chiron's retrograde motion and dove deep into the ancient oceans of Ceres.
We want to thank you, our listeners, for joining us on this journey today.
We'll be back tomorrow with more of the latest news from the cosmos. Until then, from me, Avery.
And from me, Anna, keep looking up. This has been Astronomy Daily.